Hello everyone, and welcome to Math Fundamentals, where we'll be exploring some basic and maybe some complicated concepts that I think are fundamental in the world of mathematics. Today we're going to cover quadratics, how to factor them, how to solve them. So we're going to cover specific methods like the GCF, diamond method. We're going to talk about perfect squares, grouping, solving quadratics, and then we'll have a special guest of the quadratic formula. So just keep in mind that the purpose of this is just to briefly cover math topics and methods. It's not really a deep trek into the material, just a quick exploration. So whenever you're ready, let's get started. Alright, so the first method is factoring out the GCF, and I think it's one of the important things that we have to remember. Every time we're looking at quadratics or any sort of polynomial, you want to look at something that perhaps they have in common. If we look at the first problem, you'll notice that they both have a 2 in common. So that's exactly what we're going to factor out. We're going to factor out a 2, and we're going to rewrite this polynomial when we remove the 2. So this will become an x, and then the other one will become a 6. Let's try the same thing using the second equation. Notice that they have a 3, and now they have an x in common. So I'll factor that out, and then just rewrite it, and make that x minus 4. Let's try the next one. What do you see? They definitely have a 4 and perhaps an x in common. So let's factor that out, and then when we rewrite the polynomial, this is going to become an x minus 6. Let's see if you can do the next one on your own. I'll give you a couple seconds. I'm hoping that we factor out a 5x from that to make that a 5x, and then inside the parentheses we're going to have an x and then a minus 7. You notice the GCF is pretty easy, but it's one of the first methods that we have to use whenever we're factoring quadratics. Let's try the next one. Now let's try the diamond method. And remember, the diamond method can be taught in many different ways. I just like to do a quick little x, where if we're working on the first problem, I will take the number, the constant, and have a negative 12, and then I'm going to take the coefficient in front of that x value. In this case is a 1. For the diamond method, all we're looking for is numbers that multiply to negative 12 and add to 1. So in this case, it's going to be a positive 4 and a negative 3. I take those two values and I rewrite my equation as x plus 4 times x minus 3. Pretty simple, huh? Let's try the next one. So I'm going to have a negative 10 on top. I'll have a negative 3 on the bottom. And again, I'm looking for two numbers that multiply to negative 10 and add to negative 3. See if you could think of those. I'll give you a couple seconds. Hopefully we chose negative 5 and positive 2. So then we take those numbers and we're going to have x minus 5 and then x plus 2. Okay? And then keep in mind, if we ever want to be reminded or we want to double check our work, we can just multiply this out. You can just use the distributive property, or you can actually use the FOIL method, which is just a very special kind of distribution property of polynomials. Alright, on to the next one. Two numbers using the diamond method that multiply to 6 and add to 7. That one's pretty simple. I'm hoping that we know that right away. It's going to be x plus 6 and x plus 1. Notice that I was so quick, I didn't even write the two numbers on here, the 1 and the 6. It's one of those things that as you continue practicing these concepts, you get so easy at it. Sometimes you don't even need to write these diamond methods here on the right side. But of course, they're going to be useful. So if you're ever confused, show your work. The next one, got to find two numbers that multiply to 9 and negative 10. That one's interesting. I think a lot of people always want to do like 1 times 9. That's it. That's my number. But you got to remember that they got to add up to negative 10, not positive 10. So in this case, both of these numbers have to be negative. Negative 1 and negative 9. X minus 1 times x minus 9. And again, if you wanted to verify that, we can use the distribution property. All right. On to the next exploration. Now, the diamond method 2.0. Everyone calls it differently. This is just the way I like to do it. What's different about this? Notice that every single polynomial or quadratic that I have here has something in front of the x squared. In this case, there's a 2, a 2, a 3, and a 6, right? There's all these different things. So when you have something like this, we can still use a diamond method. Again, some people do this so differently. Some people call it the illegal move. Some people just call it grouping. But if I'm going to use a diamond method, what I'm going to do is the first thing that I'm going to multiply by is a 2 times a 6. And that's going to become a 12. So using the same process as a diamond method, I'm going to have a 12 on the top, and then I'm going to have a 7 on the bottom. So again, I have to think of two numbers that multiply to 12 and add to 7. So that's going to be 4 and 3. Now keep in mind, this is what the diamond method 2.0 is about. Because we multiplied by 2, I'm going to have to divide the numbers that I found by 2. Okay, and then I'm going to try to simplify these fractions. On the left one, 4 over 2 just becomes 2 over 1, which is really nice. And then 3 halves becomes 3 halves on the right side. We don't do anything with it. But these fractions are going to be important because what's going to happen is we're going to use the denominator. So in this case, we have the 1, and that's going to become my 1x. And then the numerator on top that I have here, the 2, that's going to become plus 2. And now I'm going to do the same thing for the 3 halves. Notice that my denominator is 2. So then I'm going to have 2x, and then my numerator is 3, and that's going to be plus 3. Okay? Again, diamond method is confusing. The diamond method 2.0 can be even more confusing, but everyone learns it differently. I like this method. I think it's pretty neat. Okay, if I do the next one, multiply 2 times negative 1, all I'm going to have is negative 2 and then positive 1. Got to look for two numbers that multiply to negative 2 and negative 1. Or multiply to negative 2, add to negative 1. I'm so sorry about that. Sometimes I get a little distracted. So that's going to become negative 2 and positive 1. Did I do anything wrong? Negative 2 times positive 1. It sure is negative 2, but it doesn't add to positive 1. So I need to change that. It actually needs to become a positive 2 and a negative 1. So I'm going to make this a positive 2 and then negative 1. And then again, because I divided or I multiplied by 2, I need to divide by 2 and then simplify our fractions. On the left side, we get 1 over 1 and then negative 1 over 2 for the next. So that becomes x plus 1 and then 2x minus 1. Okay. The next ones do the same thing. Illegal move, multiply 3 times negative 8, negative 24, and positive 10. I know for sure that those two numbers should be 12 and negative 2. Divide both sides by 3 and simplify to the best of our ability. Look at that. X plus 4 times 3x minus 2. Alright, last one. 6 times negative 1. Let me create some space here. So I'm going to have 6 times negative 1, negative 6, and then it has to add to negative 5. Think about those numbers. Let's just try negative 6 and positive 1. Divide both sides by 6 and simplify those fractions. So we get x minus 1 and then 6x plus 1. All right, cool. Now, sometimes we've done the GCF, we did the diamond method, and then there's a diamond method 2.0. Sometimes there's going to be special quadratics like perfect squares. These are really neat because all they become is x plus 5, x minus 5. Hopefully you can kind of see it. And again, this is just a refresher. This is not a deep dive. So we should just be able to recognize these with practice. The next one, x minus 6, x plus 6, and then we have the last two. These are interesting because notice that there's a 4 and there's a 9 in front of the x squared. So think of the square roots of those. And we get 2x minus 9. And then 2x plus 9. And the same thing for the next one. 3x minus 12, 3x plus 12. These are so satisfying because they just, simplify so easily. All right, so we have perfect squares. The next type, and these are easy to recognize. Notice that we have 4 terms instead of a, typical trinomial. All we're going to do is we're going to group each 2 values and factor out something, factor out a GCF. So for the first group, I'm going to go ahead and factor out. Let's do a 2x. So when I factor out a 2, well, that is not a 2x. I'm going to factor out a 3x. Sometimes we all make mistakes and we just come back and fix them. So I factor out a 3x, and then for the next group, I'm going to factor out a 2. And then that becomes, see, again, not even a 2. I'm like overthinking this. It should be a 4. So 4, and then this is going to become an x plus 2. Now, it's important to make sure that we factor this out completely because you want to have the same factor on both sides. So you want an x plus 2 and an x plus 2. If you did that, you've factored this successfully. And now what we have is we have the x plus 2. And then we're going to take the two factors that we have and create that into its own little binomial. There you go. X plus 2 times 3x plus 4. Let's do the same thing for the next one. I'm going to group these. For the first one, let's factor out a 2x squared. And then I get x plus 3. And then for the next one, this one's interesting. I'm just going to factor out a 5x. Hopefully we get the same thing. We sure do. And then let's take those two factors that we had outside, and then the x plus 3 becomes our parentheses. The next one has an error that I noticed as I was recording this. So we're actually just going to skip that one, not even worry about that, and just move on to the last one. So if I factor out a 2x from the first group, that becomes x plus 3. And then the next one, there's not much to factor out, but we can always do a negative 1. And this becomes x plus 3. And then I'm left with 2x minus 1 and then x plus 3. That's grouping for you. Let's try the next method. So now that we learned about the ways to factor this, now we got to talk about how we even solve these things. Whenever you solve quadratics, just keep in mind you want to set everything equal to 0, meaning you want all the values on one side and all a 0 on the other side. And then you factor out and then you solve. So for example, the first one, it's already set equal to 0, which is really nice. So I'm going to factor this out using the diamond method. Okay? Two numbers I multiply to negative 3, add to 2. That becomes x plus 3, x minus 1, and then that equals to 0. Notice that we have both of these things being multiplied together. So the long way is we set both of these values equal to 0, and then we solve for x. And at the end, we get that our answer is going to be negative 3 or positive 1. We could write our answer like this. Some teachers want you to write it in like the little squiggly line parentheses. Totally up to you. All right, this next one. It's a little different because we have an 84 on the right side. So we need to go ahead and bring that to the other side. Not necessarily factor it out yet, but bring it to the other side. So when I do that, I get a minus 84 on the other side. And notice that I can technically factor out a 2. So always watching out for that GCF. And that becomes x squared plus x minus 42. And then I can use a diamond method, but I'm just going to go ahead and write this down with enough practice. Keep in mind that we get so much better at this. And again, the long way is we set x plus 7 equal to 0, x minus 6 is equal to 0, and then we get our solutions negative 7 and positive 6. Okay? The next problem, move everything to the other side, so this becomes 2x squared plus x minus 6 is equal to 0. Can't really factor out a GCF, so I definitely have to use the diamond method 2.0. And whenever I use this, I don't really trust myself. I have some students that are really good at this, and I'm always just amazed at how they can do all this work in their heads. Not me, man. Just doesn't work for me. Okay, so using the diamond method, I'm going to multiply 2 times the negative 6, so negative 12, and it adds to 1. That's 4, negative 3. And then I'm going to divide by 2, simplify these, and then this is my answer so far. I'm going to get 2 times x plus 2 and then 2x minus 3 is equal to 0. And again, this is where you have to set x plus 2 equals 0, which makes x equals negative 2. One solution, and then we have 2x minus 3 is equal to 0. And then we get x is equal to 3 halves. Okay, so we've been doing all the factoring stuff. This next one's, hopefully we can recognize that we have 4 terms, so we should definitely solve this using grouping. Okay, so if I factor out the first group, all I really have to factor out is the x. So this becomes 5x minus 4. And then I'm going to factor out a minus 5 from the second group. That becomes 5x minus 4 as well. Yay, we have the same parentheses. So this becomes x minus 5, and then 5x minus 4 is equal to 0. If we show all the work at the end, we're going to get x is equal to 5 and x is equal to 4/5. All right. Now, last thing, and I think I talked about our special guest. If we can never solve a quadratic by factoring, using the GCF, by using the diamond method, grouping, whatever method we learned so far, there's one equation that will always, and I mean always, give you the answer. And that is the quadratic formula. So as long as we have everything set equal to 0, we can go ahead and use this formula. And hopefully by now, you're at a point where you recognize this and you say, oh yeah, I exactly know what to do here. Okay, so you set everything up and we find the zeros. Okay, and that's all for today. Again, this isn't supposed to be a huge deep trek into the exploration of quadratics. This is all just a little, a gentle visit into the world of solving quadratics. All right, I hope you enjoyed, and I'll see you next time.